everybody, this is Mr. V, your chemistry teacher. Today's objective is two things. One, we're going to review how to find valence electrons, and two, we're going to determine how to find the charge of stable ions. So feel free to skip to part 2 if you already know how to do part 1. All right, so real fast, part 1, if you want to find the valence electrons, you got to find the group or the column that it's in. So for example, all the elements in this column right here, they all have one valence electron. So lithium has one valence electron, same with sodium, potassium, so on. All the elements in this column has 2 valence electrons. We're going to skip the transition metals because it varies for their valence electrons. And then all these ones right here have 3 valence electrons. So aluminum is going to have 3 valence electrons. So I'm going to put 1 on each side here. Okay. And then so on. So all of these elements right here have 4 and so on. Let's do another one for sulfur. If I look at sulfur, it's going to be group 6 right here. So it's going to be 6 valence electrons. I'm going to draw it one at a time first. And then I can fill in the other sides. So there's 6 there. For sodium, sodium's in this first column, so it's going to have 1 valence electron. All right, so very easy to predict just looking at the periodic table, depending on what column it's in for valence electrons. All right, part 2 is we're going to determine how to find the charge of the stable ion. So to do that, we first got to find the valence electrons, which we did. And the key thing to note is that if you want to be pretty much stable, you're going to need to have a full set. So that's going to be usually 8 electrons or none, or 0 electrons. And I'm gonna show you in a little bit why it's normal, why it's also okay to have none. So let's look at aluminum first. I want to find the charge of aluminum. So there's 2 scenarios that can happen. I can either gain electrons to get to 8, or I can remove electrons to get none. So you want to do the ones that's less. So you see, it's much easier to take out these 3 electrons. Okay, and if I do that, then remember electrons are negative, and so when I take those 3 out, overall the aluminum is going to be a positive charge when you remove the electrons. Okay, another scenario that could have happened is if I were to gain 5 electrons instead. If I gained 5 electrons instead, that technically would be stable, right? And it would have aluminum, but with a 5 minus charge. But see how like 5 is a lot higher than 3? That's it's much easier to just remove the 3. This is just too much energy, so we can eliminate that part. All right, so that's aluminum. For aluminum, the reason why we were able to take out 3 electrons is because if we take these 3 out right here, notice that we still have a full set, right, of like 8 valence electrons there. So that's why it's okay for that. That's why aluminum is stable, because even if there is none on this orbital or shell, then I will still have a full set in the other energy level. For sulfur, let's do sulfur next. It has 6. Remember, it needs 8 electrons or none to be stable. So the reason why, so if you think about it, there's 2 choices. I can either gain 2 electrons or I could lose 6, right? So for this one, it's much easier to just gain 2 more. And when I gain 2 more electrons, that charge is going to be a negative 2 charge. So I put it a 2 minus there, but if you put -2, that works too, but this is more common in textbooks. All right, so that's sulfur. Let's try one more for sodium. For sodium, it has 1 valence electron. And so there's two choices, right? You could either lose that 1 valence electron or you could gain 7 more. So it's much easier for it to lose this 1 electron, and so total it's going to be, electrons are negative, so if I lose 1, it's going to become +1. Okay, and so that's just a simplified version of like how you get the charges. So I just want to point out one thing. So let's look at sodium. We discovered that this is a +1 charge, right? Well, if you look at the patterns, all of these elements also have 1 valence electron. So all of these elements, if you want to look at their charge, they're all going to remove 1 electron. That's the easiest one. And so if you're just looking at charge, all of these elements in this column is going to have a +1 charge for their ion. Okay, same thing for this sulfur with the -2 charge. All of these elements have 6 valence electrons. So like oxygen, for example, also has 6. And it's way easier to gain 2 more electrons, rather than to lose that 6. So all of these over here are going to have a -2 charge. So -2 charge in this column. But I wanted to show you how we got the charges and not just memorize. So if you draw the Lewis structure, it's easy, or not easy, but you can see where they came from, how we got the charges for that. Last thing, the only exception is hydrogen and helium. Hydrogen and helium are perfectly fine with 2 electrons. Remember, the first energy level or subshell is satisfied with just 2, is stable with just 2 electrons. But other than that, the main takeaway for this is you want that full set of 8 electrons or none when you want to find the charge. Okay, hopefully that was helpful, and hope you enjoy the rest of your day. Okay, bye everybody.